If you want to follow along, I recommend this dbfiddle website. It's a free website and you don't even need to create an account. When you open the website, just click on SQL Server, that's the flavor of SQL that we're using for these videos, and make sure you choose AdventureWorks as the database. That will give you access to all of the same sample data that I'm using in these videos. Today we're going to be talking about the dreaded join in SQL. Joins are actually something that we're really familiar with in Excel. So they're not quite as scary as some people make them out to be. But we will see that although there are a massive amount of similarities between SQL joins and the Excel lookups, there is one specific place where they are very, very different. And that one place where they're very different is super important to keep in mind. For this video, we are going to use some more sample data, just like in the conditionals video. That means that you won't have access to this in the AdventureWorks database. So if you're following along in dbfiddle, you won't be able to run the same queries that I'm running right now. However, I will include some SQL code in the comments or the description below so that you can copy and paste that as a template and then run the queries that I'm running today. What's the point of the join? Well, so far we've been working with one table at a time. But really the way that SQL wants to be used is that you want to use information from several tables all in one go. And that's where we're going to use the join. The join allows us to combine information from different tables in one SQL query. For today's video, the sample data that we're going to use is some sample employees, some sample departments, and some sample addresses. Like I said, this is data that I've just thrown together for this example. But just to prove that I can also see this in SQL, let's open the employee file, the employee table. Let's open the department table, which is different to the AdventureWorks department table. And finally, the address table. So we can indeed see each of these in SQL as well. So these are what we're going to be working with today. As always, let's start with an Excel example. On the employee table, we've got the employee ID and the employee name as well as their department ID, but we don't have the department name. The department table has the mapping between the department ID and the department name. So if we wanted to see the department name next to the employees rather than just the department ID, we can use one of the lookup functions to grab that information from the department table. So let's do that now. I'm going to pop in a new column, let's call it department name. Just to make it clear that this is from outside of this table, I'm also going to color it orange, just to remind us that it's not usually in this table. Now there's a bunch of different lookup functions that you can use. I'm a big fan of XLOOKUP, so I'm going to use the XLOOKUP function. That's XLOOKUP. I'm going to look up the department ID in the employee table. I'm going to be searching the department table's department ID. And when I find a match, I'm going to be using again the department table with their department name column. And if I don't find a match, let's just leave it as blank. So we'll finish there. Here we go. So just so you can see this, I'll put these on a new line each so it's super clear what everything's doing. So we're looking for the current department ID, searching for that department ID in the department table's department ID column, and when we find it, we return the department name from the department column. From the department table, sorry. So this has worked exactly like we expect. All we're doing is 1 maps to sales, so we've got sales here. 2 maps to marketing, so we've got marketing here. And 3 doesn't have a value in the department table. So at the moment, we're just seeing an error. So let's try and redo this in SQL. How are we going to do this kind of lookup in SQL? When we do this with SQL, we're still going to start with the employee table. So the employee table is still coming after the from, just like normal. Let's run this just to make sure that we can open it. We sure can. Now what I'm going to do, I'm just going to explicitly write out the columns. So we want the employee ID, the employee name, and the department ID. Now the way that we're going to do the lookup from the department table is by writing a join. That's the way that SQL thinks about lookups. It defines them as joins. And the way that we do it is slightly different to Excel. With Excel, we need to do an explicit lookup on the column every single time. But SQL, because it expects us to be doing lots of lookups, it says that we can define a relationship between two tables, and then we'll have access to all of the columns after we've done that once. That might sound a bit mysterious, but let's actually see this in let's actually see this in practice. What I'm going to do, I said that we're going to need information from the department table. So I'm going to write left join department. There's actually lots of different types of joins. Left is just the most common. It's the one that we're going to start with, and we're going to go through one other one later on. But left is always the one that you want to default to. So I'm going to write left join department. And now we need to define the relationship between these tables. How do we associate rows in the employee table with rows in the department table? Well, that might sound confusing, but that's actually what we're doing with the lookup. We're saying, well, how do we associate this row with the department table? We associate it with the department ID in the department table. And what we're going to have to do is something similar here. We've had to say that we're looking at the department ID specifically on the department table in Excel. We're going to have to do the same thing in SQL, because otherwise SQL won't know whether we're talking about the department ID in the employee table or the department ID in the department table. So to define this relationship, after we've written the join, the left join, we need to say how they're related. The way that they're related is on the employees, the employee department ID, where that's equal to the department's department ID. This looks a bit funky, but this is exactly the same as what we've done in Excel. We've just rewritten it in a slightly different way. But really, when Excel does this lookup, it's looking for the places where the department table's department ID is equal to the employee table's department ID. So that's why we've written it here with the equals. It's exactly the same thing. And I mentioned that we need to prefix the department ID with employee or department to make it really clear to SQL which one we want to use. We're going to need to do the same up in the select as well. Was this department ID the one from the employee table or the one from the department table? Let's use the one from the employee table. And while we're here, although it's clear that these two come from the employee table, let's prefix these as well. It's a really good habit whenever you're doing joins to prefix every single column. SQL might not require it, but it's a really good thing to do for anyone that's reading your code, because then it becomes very clear where each of the columns are coming from. It's clear that this one, and this one are coming from the employee table. Now, I've defined the relationship. I've said that I want to do a lookup on the department table, and the way that we're doing the lookup is, the way that we're associating these tables is where the employee's department ID is equal to the department's department ID. How do we use information from the department table now? Well, we just write it in. So let's do the department.departmentName. We've already defined the relationship between these tables, so now we can just specify the column. Let's give this a run to see what we get. Here we go. We get exactly the same thing as in Excel, more or less. We get the same sales and the same marketing. Excel has these error messages sometimes. SQL doesn't have error messages in the cells. If it can't find anything, it just shows us the null value, the missing value that we've seen before. Just to be super clear with how this is working, because I appreciate the way that we've written it does feel quite different to the way that we've written the lookup. Let's walk through this line by line. So I'm going to pull up the department table just so that we can see what rows we're looking at in the department table, and we'll walk through the employee table line by line just to see how we're getting this department name. We'll start with line 1. Start with Alice. Their department ID is 1. So when we do the lookup on the department table, we're going to keep the rows where the employee's department ID is equal to the department's department ID. Well, if the employee department ID is 1, we're going to keep the department rows where the department ID is 1. That's this row. So when we ask for the department name, well, that's specifically sales. It's exactly the same with line 2. Department ID is 1, so we keep the row in the department table where the department ID is 1, and when we ask for department name, we're going to get sales. When we're on line 3 with Charlie, their department ID is 2. So when we look for the row in the department table where the employee department ID is equal to the department ID, well, that's going to be where the department ID is 2 in the department table. So that means that when we ask for the department name for Charlie, we're going to be getting marketing. And it's exactly the same for Dave. Their department ID is 2. That corresponds to this row in the department table. So when we ask for the department name for Dave, we get marketing. And finally, when we look for the department for Eve, we're trying to look for the row in the department table where the department ID is 3. Well, there is no row. And so when we ask for the department name for Eve, we haven't found anything. So the only thing that SQL can do is say, well, I haven't found anything. And the way that it does that is by using null. It's the missing value. It couldn't find anything, so it's left as missing. So really, Excel lookups and SQL joins, they're really, really similar. We just need to think, we're not just looking up a particular column. We define the relationship between the tables, but really if we were doing several lookups in Excel, we would just be reusing that relationship anyway. It's always the department IDs are equal. That's the relationship between these tables. When we did the lookup, we used a left join. Now I'm actually going to explain what left join means in SQL. Left join just means keep everything in the base table, the table that's listed after from, and if there's information in the department table, whack it on. That's exactly what we've seen. So we had 5 rows in the employee table, and where we could find information in the department table, we whacked it on. Another type of join is the inner join. And in fact, if you don't write left or inner, you just write join by itself, it defaults to inner join. Now an inner join does something a bit special. An inner join will only keep the rows where it can find information in the joins table. Let me run this so we can compare the output and you'll see what I mean. So if I give this a run, we've lost the Eve row. We've lost the Eve row because we couldn't find any department information for Eve in the department table. When we did this check, we couldn't find any rows. What inner join will do is it will then drop any rows that it couldn't find any information for. This can be a bit unexpected. And in particular, if you don't write inner join, you just write join, you might suddenly start losing rows without even realizing. So my recommendation, always start with a left join, unless you specifically want to be losing the rows where you can't find any information in the table that you're joining to. In every other way, left join and inner join are pretty much the same. You see that we've still got sales and marketing for the other 4 rows. It's just that one row for Eve. We couldn't find any information for Eve in department. So inner join means that we're going to completely ignore that row. We couldn't find any information. We're going to ignore it. Now let's do a join where we can find multiple matches for a particular row. So we're going to start with the employee table again. This time, let's look at the address table. Let's do a lookup on the address table, and note that Eve, though they didn't have any matches in department, there's actually 2 rows that correspond to them in the address table. So let's see what happens in Excel first, and then we'll compare that to what happens in SQL. And in this case, there's 3 columns. Let's go ahead and grab all 3 columns. So let's paste in these columns. Again, let's color these orange so that we know that they're from outside of this table. Just because it's my preference, I'm going to use XLOOKUP again. So we're going to do XLOOKUP. Now, how do we associate these tables? Well, last time it was on the department ID, but this time it's on employee ID. So we see that we've got the employee ID here, and we've got the employee ID here. That's the relationship between these 2 tables. It's the employee ID. So we're going to do a lookup on the employee ID. We're going to look for the address tables employee ID, and then we're going to return, since this is the address column, let's return the address. Same as last time. If we don't get any matches, we'll just see the NA. Let's do the same thing for the from date. I'm just going to change address to from date, and similarly we'll do the same thing for to date. We'll change from date to date. We'll format these as numbers. Excel's being a bit funky by thinking that they're text, so we'll format them as dates, sorry, so we'll do that. And now we've done our lookups onto the address table. I'm going to make 2 comments here. The first is just proof that we're reusing the same association for all 3 columns. The only thing that's changing is that last column, the column that we want to keep after we've found the employee IDs. And so this is why SQL streamlines this part. That's why we write it once in the join, so that we can then just pick the columns that we care about. The second comment I'm going to make is what happened with Eve. Eve has 2 matches. So what's Excel done? Well, Excel's just picked the first one. It's only picked this line here. That's going to be really significant when we go around to SQL. So let's do exactly the same thing in SQL and see what the output looks like. With SQL, we're going to start with the employee table again, but this time we're going to do a join on the address. Now, to match what we have in Excel, we're going to do a left join. We don't want to drop these 2 rows. So let's do left join to the address. What's the relationship between these? Well, if we click on one of these, it's on the employee ID this time. So this time we're going to do on the employee ID equals the address employee ID. This is more or less identical to what we wrote last time. Last time it was department with department ID and department here. This time it's address with employee ID. And we know that it's employee ID for each of these because they're the first 2 conditions in the XLOOKUP, the first 2 parameters in the XLOOKUP. All 3 of them have the same relationship. We can just write it once in SQL. So that's how we're going to do the join. Let's write out some columns that we want. So let's start with the employee ID. We're also going to want the employee name. Let's keep the department ID, even though we don't really care about it right now. And then next, we're going to want the address information. And now, since we've defined the relationship once, we can just write the address columns just straight away. So we could do address, from date, and to date. We've defined the relationship once, but we can reuse that to grab each of the columns. So I've written my code, let me run it. What do we get on the output? Let me actually hide the department ID for now. just some noise that we don't particularly care about. What do you notice? SQL has kept both rows for Eve. This is the most important difference between Excel lookups and SQL joins. Excel lookups, if they find multiple matches, they'll keep the first one. In SQL, it will keep every match. If you're not expecting this, this can be the cause for some unusual results. So it's really important to know this is what happens. And let's walk through why this happens. So same as last time, let's go through these step by step. So let's start with line 1. We'll start with Alice. Their employee ID is 1. So when we do the lookup on address, we're going to keep the rows where the employee ID is 1. Let's scoot over to address. That means we're keeping this row. So when we ask for address, from date, and to date, we're going to get this address, this from date, and this to date. Similarly with Bob, employee ID 2, when we do the lookup on the address table, we're looking for where the employee ID equals 2. The rows that have employee ID equals 2 is just this one row. So when we ask for the address, the from date, and the to date, we're going to get these 3 cells, these 3 values. Easy peasy, just like the previous example. Similarly, Charlie and Dave, employee IDs 3 and 4. Well, there are no rows where employee ID is 3 or 4. And so in every case, in each of those cases, we're going to get nulls. SQL can't find anything for Charlie and Dave, so it just spits out null. Now, Eve, this is the special case. When we do the lookup on the address table, we're asking for the rows where the employee ID is 5. There's 2 rows where the employee ID equals 5. And so when we ask for the address, the from date, the to date, well, there's multiple choices in both cases. So SQL is just going to give us both back. It doesn't know if we want to keep just the top one or just the bottom one, or if there was 3, the middle one. So it's going to give us all of them. And it will leave it up to us to then figure out which of those ones we want later on. So this is the crucial difference between Excel and SQL. Excel keeps the top match, SQL keeps all matches. Just so that we've seen it, what happens if we had used inner join instead? Well, let's write inner join. What do you think is going to happen? We're going to lose Charlie and Dave. We couldn't find any information for Charlie and Dave in the address table, so we ignore them. We drop them. And just to prove it, let me stick this back to left for the moment. If we hadn't written left or inner, we just write join, and we run this, it's still doing the inner join. So always be, or this is my recommendation, always be really explicit about what type of join you're doing. Always write left or inner or one of the other ones that we're not going to cover. If you just leave it to join, you might forget which type it's doing. In the same way that we can do multiple lookups in Excel, we can also do multiple joins in SQL. So we've seen that we can join the department table onto employee. We've also seen that we can join the address table onto employee. Can we join both at the same time? Of course we can. So let's do that now. For now, let's just do both as a left join as well. So we'll start by doing a left join to department. And what was it on? It was on the employee ID. No, it wasn't the employee ID, it was the department ID. And this one was equal to the department's department ID. That was the relationship between these tables. How did we then join employee to address? Did the same thing. We'll do address, and this time it is on the employee ID. So you see, to add multiple joins, all we need to do is specify multiple joins after the from. Now let's pick out the columns that we want. We're going to want the employee ID. Let's take the employee name. Oops. Let's also do the department ID. So these are the 3 columns from the employee table. Let's grab the department name from the department table. So department.departmentName. We know how to get this because we've done the join to department. And let's also do just address.address. We'll forget about the from date and to date for the moment. We'll just keep the address. So that's 2 joins onto the employee table. We're combining all 3 tables in this SQL query. So let's give it a run to see what we get. Here we go. We'll expand this a smidge to make it a bit. Let's hide the department ID for now. We'll skip that, just so that we can see it a bit clearer. So we can see that we've now got 6 rows, but we do have the department name and the various addresses. We get 6 rows because there's 2 addresses for Eve, and SQL is going to keep them both. This was 2 left joins, which is why the department name for Eve is null. Remember, there's no department for Eve in the department table. And the address for Charlie and Dave is null because there's no address information for Charlie and Dave in the address table. Just so that we've seen it. What would it look like if we changed these left joins to inner joins? What do you think? We just get Alice and Bob. We lose Charlie and Dave in the address join, and we lose Eve in the department join. That means that we're only left with Alice and Bob. We can mix join types if we want. We can have this one as a left join, and the other one as an inner join, or the other way around. Let's make that one inner, this one left. It's totally up to us. You can have both left, both inner. Really, it's up to you. Just make sure that you use the one that's right for your specific scenario. Another thing to mention, we saw that we can alias, we can rename columns with the as keyword. So we might, for whatever reason, want to short name some of these. So we could rename the employee ID to EmpID, employee name to EmpName, and department name to DepName. I'll run this just to show that it changes the output. Here we go. We could do the same thing with the tables. Now, in this particular case, maybe this isn't the most appropriate place where we'd want to rename or alias the tables. It's usually more appropriate for when you've got much larger table names because you don't want to keep rewriting them. But let's show how it would look anyway. So we could rename this to emp, and then anywhere where we've used employee would actually have to write emp. So this is now emp, this is now emp, this is emp, this is emp. I'll run this just to prove that it works. The output's exactly the same. Could do the same with department. Let's rename this as dep. So anywhere that we've written department, we now need to write dep. We could do the same with address. We might want to call this add or adder. Add's a special word. So we could do adder, not that one, sorry. That one's adder, that one's adder. I'll run this just to prove it works. Here we go. These table aliases, like I said, in this case, not super helpful because the table names are already appropriately short. But if this was a very long table name, adding an alias is a great way to then reference that table name in a much more concise way. Let's go back to the join between the employee table and the address table. Our joins so far have been pretty simple. Just one column equals another column. But actually, we can have as many conditions as we want. Let's show an example of this. Let me rerun this join so that we can see what comes out. We've got all 4 of the rows from the address table now in the output. We can add more conditions after the on just by using and or again, just like in the where clause. So we could add another condition, say the address from date needs to be, say the year of the address from date needs to be greater than 2010. Let's just take a quick second to check which rows this would be. The from date are these 4 rows. Well, let's check them in Excel because we've already got the join over here. The from date is these 4 rows. So which ones have got a year that's greater than 2010? Well, it's this one, and it's this one. Line 3 and line 5. So I'm actually expecting that when we do the join, to only keep these 2 rows. Let's run this to confirm. Absolutely. Only 2 Rocky Road and 6 Claw Close. And note that we've no longer duplicated the information for Eve, because we only have 1 row that would be joined onto her. Just to make this super clear, let's walk through this one line by line again. So the first line, Alice, employee ID 1. Let's do the lookup on the address table. We're looking for the row whose employee ID is 1. We've got this one. But additionally, we need the address, we need the from date to be greater than 2010. Is this greater than 2010? No. So this is equivalent to finding no rows, which is why we get no information for Alice. Let's move on to Bob. Employee ID 2, that's this row. Is the from date greater than 2010? It is. So we'll use these 3 values in the join. We didn't have any Charlie and Dave to begin with, so they're still null. And finally with Eve, we first find the rows with employee ID 5, that's these 2. But then additionally, we need the from date to be greater than 2010, which is only this row. Which means that when we grab the address information for employee ID 5 for Eve, we're only using this information. This is a bit more advanced. It's unlikely that you'll need to do this anytime soon, but it's just worth knowing that you can make your joins more complicated if you need to, or you can add more conditions if you need to. But just be careful. Like I said, it takes a bit of time wrapping your head around using joins in this way, because this is then a bit more of an extension compared to the Excel equivalent. But it's a good thing to know about. To wrap up, we've seen that joins in SQL are really similar to lookups in Excel, with one key difference. If we find multiple matches in a join, we keep all of them. So keep that in mind. That's really, really important. It's the crucial difference between SQL joins and Excel lookups. The joins that we've gone through today are left join. We can left join department. And anytime you do a join, it needs to be on some condition. So in this case, it was the department ID from the employee table is equal to the department ID in the department table. We also saw that we can do inner joins. And inner joins are a bit special because if they didn't find a match in this join, they're going to drop the rows whose information they couldn't find. So when you're getting started with joins, where you're getting started with new data that you don't recognize, that you're not familiar with, my recommendation is start with the left join. Get to know what data is available and what data is missing, and only move to the inner join when you're comfortable that that's what you want to do. Always be explicit about your join types as well. No join type prefix means that it's an inner join, and that's the join type that can drop some rows. So be explicit. Joins are a fundamental part of working with SQL. So practice them, practice them, practice them. Almost any SQL query that you write is going to join some data. It's going to join some tables because it's so common to need to get information from separate tables before we do stuff with it. But I hope that you found this helpful, and we'll catch you in the next one.